Good evening to everyone. My name is Venu from Easy. Today I am telling about the topic random process in probability theory and stochastic process. Introduction to random process. Introduction to random process. A random process, stochastic process is a collection of random variables that change with time. In simple terms, it is a time varying random signal. A random process is a collection of random variables indexed by time or space, used in fields like engineering, space, and finance. Examples: noise, stock market, fluctuation, weather changes. The, the another definition of the random process is a random process is a time varying random phenomenon described statistically using tools like PD, probability density function, probability destination function, correlation, correlation, covariance, with the help of understand and model signals such as noise and message signals in communication system. The other definition of the random process is a random process or stochastic process is a process in which a random variables depends on both the time and sample space is called a random process. The examples of random process are message signal in communication, background noise in receiver, variations in weather, temperature or rainfalls, speech music signals, speech music signals. In random process, we have infinite energy. That why we study infinite energy function, correlation function, autocorrelation, covariance function. Basic concepts: sample space, set of all possible outcomes, random variable, assign a numeric value to each other, discrete or continuous, stochastic process, a family of random variable representing system evolution over time. Types of random processes. Types of random processes: discrete time random processes, index set is discrete, example daily stock prices. Continuous time random processes, index set is continuous, example temperature over a day. Practical example for each type. Classification of random processes. Classification of random stationary processes. Statistical properties remain constant over time. Non-stationary process properties change over time. Ergodic versus non-ergodic relationship between time average and ensemble average. Classification of random process are four types: continuous random process, continuous random process, discrete random process, continuous random sequence, discrete random sequence. In continuous random process, if both time and random variables are continue. In discrete random process, random variable discrete values, time is continuous values. Continuous random sequence, time is discrete, random variable is continuous. Discrete random sequence, time and random variables are discrete. Properties and parameters: mean, expected value, variance, autocorrelation, how values relate over time, autocovariance, measures linear dependence at different times. Deterministic and non-deterministic. Deterministic process, the value of the signal can be exactly predicted. Non-deterministic process, the value of the signal cannot be exactly predicted. Examples of random process: Poisson process, modeling count events, example phone calls hours. Gaussian normal process. Value follow normal distribution. Binomial process. Series of independent Bernoulli trials. Applications: signal processing, noise reduction and filtering, communications, data transmission error and modeling, finance, forecasting and risk estimation. Illustration case study. Illustration case study. Example: random process in weather forecasting. How random process help model temperature and rainfall variation. Real world impact and predictive capability. Conclusion: random processes are essential in many disciplines. Help in modeling, analysis, and prediction of uncertain system. References: Pauli, probability, random variable, probability, random variable, and stochastic process. Additional resources are needed. And mean value output response. Consider a random process x of t is a wide sense stationary process, which means its mean value doesn't change with time. The mean value of the output response is given by e of y of t. For a linear time invariant system, y of t is equal to integral minus infinity to infinity h of tau in x of t minus tau dt. And means power spectral density means the power spectral density of the wide sense stationary of the random process x of t is obtained by the Fourier transform of autocorrelation function rxx of tau. Sxx of omega is equal to minus integral minus infinity to infinity rxx of tau into e power minus j omega d tau. Conclusion: random processes are essential in many disciplines, help in modeling, analysis, and prediction of uncertain systems. Thank you.